Okay, so today we're going to talk about integration of composite functions. So if you remember what a composite function is it's basically a function within a function. So if we look at this first one right here, f of x is equal to sine 3 of x. So the outer function is this sine of x. The inner function is the 3x. Okay, so those are composite functions. It's the function within the function. So to integrate these, we have to kind of think back to the chain rule. Okay, and so through this process here, we are going to discover kind of the backwards chain rule, or undoing the chain rule. Now, Khan Academy has a great video series for this that I think would be very beneficial to watch before going through these steps. And that is in the Google Classroom. But first of all, we are going to start by taking the derivative of f of x. So f prime of x, and because we have to do the chain rule here, well, the derivative of sine is cosine. You keep the inside, and then you multiply by the peanut. Okay, so this turns out to be 3 cosine of 3x. Okay, so to integrate this, we want to integrate 3 cosine of 3x and then dx. To integrate this, there's a couple things that you need to look for. You need to look for the inside function, which would be the 3x here, and then you need to look for the derivative of that. Okay, well, the derivative of 3x is 3. Okay, and so here's how we integrate this. I call it u substitution. So what I'm going to do is I'm going to set u to equal this inside function here, this 3x. So then I take the derivative of u, so du dx is equal to 3. Okay, so in this integral here, I have 3 dx left over. So the 3 dx. So we can look at this du dx as kind of a fraction. It's not really, but we can pretend it is. And if I multiply by dx on both sides, then I get du is equal to 3 dx. Okay. So what I'm going to do is I'm actually going to do some substitution in this integral here. So now, instead of integrating this 3 cosine 3x, I'm going to integrate cosine. The 3x is now the u, and 3 dx is du. Okay, this is much easier to integrate. What is the integral of cosine? Well, that's sine plus a constant. But we did not integrate in terms of u, we integrated in terms of x. So we need to plug back in the 3x in for u. So this would be sine of 3x plus c. That is the integral. Okay? And you just go through the same process for the rest of these. So look for the inside function. For the second one here, the inside function is going to be the cosine. So the derivative of e to the cosine of x, so we have to do chain rule. So the derivative of e is just e to the cosine of x, and then we have to take the derivative of cosine, which is negative sine of x. So this next page here is just a drill and kill. This is just use substitution over and over and over. So we are going to get really good at it. Now I recommend that you finish this page and then try the first page of the homework, okay? So if we look at this first one here, 3 cosine of 3x dx, okay? Look for your inside function. That's going to be the 3x. That is your u. So if you take the derivative of u, you get 3 dx. Now 3 dx is already in the integral, so we're good there. So I can rewrite this as cosine of u du. Okay, so the integral of cosine is sine, and you have to add that constant. Then we turn it back into terms of x. Okay, now anytime that you are doing use substitution, it is always a good idea to check. Okay, and the way that you check is you just take the derivative. So d dx of sine of 3x dx, or I'm sorry, 3x plus c. So the derivative of this, well, the derivative of sine is cosine. And then you need to do the chain rule. So derivative of 3x is 3, and that's what you started with. Okay. If we look at this next one here, this 2 sine of 2x plus 3, again, look for your inside function, which is going to be the 2x plus 3. That's what you will make u. So that means that du is 2 dx. And we do see 2 dx in the integral there. Okay, so I can rewrite this as the integral of sine of u du. Okay, the integral of sine is negative cosine. Okay, and then we just need to turn it back into terms of x. So u was 2x plus 3 plus c. Don't forget that constant at the end. Okay, I'm going to switch over here and go through a couple of these. So this first one here, this is 2x and then the cube root of x squared plus 5. Okay, this is not 2x cubed. I know it kind of looks like it. So look for your inside function. That will be your u. So you take the derivative, you get 2x dx, which you do see in the integral. Okay, so this right here is your du. So then you just rewrite as the cube root of u du. Now I'm going to go ahead and rewrite this as a rational exponent, which is u to the 1/3 du. If I integrate u to the 1/3, I get u to the 4/3 divided by 4/3 plus c. Okay, keep, change, flip. Okay, 3/4 u to the 4/3 plus c, and then turn it back into terms of x. So 3/4 x squared plus 5 to the 4/3 plus c. So this next one here, look for the inside function. Now whenever it's a rational, it can be very difficult to find the inside function. So look for the highest exponent, and that will probably tell you what your inside function is. So if you take the derivative of this, you get 2x plus 2 dx, okay, which does appear in the integral. Okay, so basically what I can do is I can rip this apart and say that this is really, and this might be a little redundant, okay, I can kind of rip that fraction apart to where now this will be 1 over u du. Okay, so this is my u, and this is du. Okay, so now we have this 1 over u, and we integrate that. Well, that should be a natural log, absolute value of u plus c. Change it back into terms of x. And that is your integral. Okay. So this next one here, okay, so this next one here, cosine 3x plus 2, so the inside function is 3x plus 2, that will be your u. Take the derivative, you get 3 dx. Now do you see 3 dx in the integral? No, you only have dx, okay? So that's what we need over on this side. So I'm going to divide by 3. Okay, so now my integral is going to be cosine of u, and I'm going to substitute for dx 1/3 du. Okay, so this is a constant, we can kick it out. Okay, well, the integral of cosine is sine. Okay, and then we turn it back into terms of x. Okay, so that is your integral. And again, when in doubt, always just take the derivative to check it. So this next one, so my inside function is going to be the x squared plus 2. That means that du is 2x dx. Now, do you see 2x dx? No, we have 3x dx. Now this 3, it is actually a constant because this is all multiplication. We can actually kick it out. Okay, so that will make things a little bit easier to see. Okay, so we still don't have 2x dx, but now we have x dx, which is something that I can get over here by just dividing by 2. Okay, so now I can rewrite this integral as the square root of u times 1/2 du. Okay, and again, this 1/2 is also a constant, so we can kick it out to where we get 3/2 u to the 1/2 du. Okay, if we integrate u to the 1/2, I get u to the 3/2 divided by 3/2 plus c. Okay, and these 3/2 will actually cancel, so you're left with u to the 3/2 plus c. Turn that back into terms of x squared plus 2 to the 3/2 plus c. Okay, this next one here, again, if it's multiplication and you see that constant, it might just be a good idea to kick it out. It makes things just a little bit easier to see. So my inside function here is going to be the 3x, so that's what I'm going to set to u. So du is 3 dx. Well, I don't have 3 dx, I just have dx, so I'm going to divide by 3. So now I leave this 5 out here. I have e to the u, and then I replace dx with 1/3 du. Okay, and again, that's a constant. We can kick it out. Okay, well, the integral of e to the u is e to the u plus a constant, and then we turn it back into terms of x. Okay. And last but not least, we have this kind of ugly looking one. Again, look for your inside function. That's what you set to u. That means that du is 4x dx. Now, do we have 4x dx? Well, no, we have 3x dx. So I'm actually going to rewrite this as 1 over the square root. I'm not going to substitute just yet. Maybe this is a little bit easier to see. Now this 3 is in fact a constant because it is multiplied, so you can kick it out. So let me just go ahead and do that right now. There's a 3 on the outside. So what I have here is x dx. So I need that over here, so I'm going to divide by 4. So I get 1/4 du is equal to x dx. Now I can do my substitution. So I have that 3 on the outside. I have 1 over the square root of u times 1/4 du. And again, this 1/4, you can kick it out. I'm going to go ahead and change this into u to the negative 1/2 du. If you integrate u to the negative 1/2, you get u to the 1/2 divided by 1/2 plus c. Okay, keep change flip. This ends up being 3/4 times 2 over 1. U to the 1/2 plus c. Okay, do some algebra here. You get 3 over 2. Then I'm going to go ahead and change this back into terms of x. So 2x squared plus 3 to the 1/2 plus c. Okay? And again, if you're ever in doubt of whether or not you're right, just take the derivative and see if what you get back is in fact what you started with. Okay? So as of right now, I encourage you to check out page 603 of the homework. Try a few of those problems to make sure that you get this down before you continue. Okay, so the second part of this video is what happens whenever we do not see the derivative inside the integral. So in each of the 8 examples above, the g prime, or the license to integrate, existed in the integrand of kind of the backwards chain rule, or g prime was attainable by multiplying by a constant. The g prime does not always exist, and there are times when it is not attainable by a multiplication of a constant. Consider the example below. So identify the inner function g of x. Okay, so like I said, it's a good tool to know how to identify the inner function. So that is the 2x minus 1. Okay, so what is g prime? The derivative of g, that would just be 2. And then if we were doing u substitution, we'd tack on a dx. So is g prime part of the integrand? So do you see 2 dx anywhere in that integral? No. Is g prime attainable by multiplying the integrand by a constant? So what we have left over is this x dx, okay? So can we get x dx from 2 dx by multiplying by a constant? Well, no, because we'd have to multiply by x over 2. The 2's would cancel, and that would give us x dx. But this is not a constant, okay? So in this case, we must find the antiderivative by a method known as U substitution. So they call U substitution different than, this is like U substitution on steroids, okay? So you're just going to follow these steps. So let U equal the inner function g of x. Okay, so U is going to equal 2x minus 1. Find du and solve the equation for dx. Okay, so du is going to be 2 dx. To solve for dx, we divide by 2. So I get 1/2 du is equal to dx. Okay, so what we've done is we've figured out how to substitute for the 2x minus 1 and the dx. Okay, now we got to figure out how to substitute for x here. And that's what this third step is. So find an expression for x in terms of u. So what we're going to do is we know that u is equal to 2x minus 1. We are going to solve for x. Okay, so that would be u plus 1 divided by 2 is equal to x. Okay, so now what we're going to do is we're going to rewrite this integral in terms of u. So our integral to begin with was x times 2x minus 1 cubed dx. Okay, so now in terms of u, well, the x is u plus 1 over 2. The inside right here is u, and the dx here is 1/2 du. Okay, so what I've done is I've replaced everything with x and I've rewritten it in terms of u. Rewritten? Yeah, that's the word. Okay, so we have a couple constants here that we can kick out. We can kick out this 1/2, and then this divided by 2 is actually 1/2 as well. Okay, so on the outside we have 1/2 times 1/2, which is 1/4. And what we have left over is u plus 1 times u cubed du. Okay, now this still looks very complicated to integrate, so let's get it into a polynomial type function. So I'm going to distribute that. So I have u to the 4th plus u cubed du. Okay, now this is something that we can integrate. So I would get u to the 5th divided by 5 plus u to the 4th divided by 4 plus c. That is my integral. Okay, so if we change this back into terms of x, so u was 2x minus 1 to the 5th divided by 5 plus 2x minus 1 to the 4th divided by 4 plus c. So it's fine to leave it like this. In fact, if you're doing a free response, I encourage you to just leave it like that. But if we wanted to simplify just a little bit more, I could distribute this 1/4. So out front here I'd have 1 over 20 plus 1 over 16 2x minus 1 to the 4th, and then 1/4 times a constant is still a constant. Okay, so I still have that plus c. Now, if you were to take the derivative of this, and it is kind of a killer to get it back to the original form, but it does work out. Okay, so I encourage you, try to take the derivative and see if you can get it to match your original integral. Okay. So now we're going to do another example, and this one again, you look at these and you know to use this super complicated u substitution whenever you don't see the derivative of g of x. Okay, so we have 2x plus 1 over the square root of x plus 4. Well, if you look at your inside function here, That would be the x plus 4. The derivative of x plus 4 is just 1, okay? And I don't see 1 dx anywhere in, well, I just see dx, okay? So we have to figure out what to do with that 2x plus 1. So I'm going to let u equal x plus 4. So that means that du is equal to 1 dx, okay? So now we need to find an expression for x in terms of u. So I know that u is going to equal x plus 4. So u minus 4 is going to equal x. Okay. So now I'm going to rewrite this in terms of u. Okay. So I have 2x plus 1 over the square root of x plus 4 dx. So right there, I'm going to plug in what x equals in terms of u, which is u minus 4 plus 1, over, and then I have the square root of u, and then I have just dx, which ends up substituting in for du. Okay? So I'm going to do some simplification here. So I distribute this guy and I add the 1. I end up getting 2u minus 7. And then what I'm going to do is I'm going to bring this square root of u up to say u to the negative 1/2 du. Okay? And so still this is not you can't take the integral of this because it's not a polynomial type function. So we are going to distribute that. Okay, now whenever you do that, you add your exponents. So 2u times u to the negative 1/2, well, 1 minus 1/2 ends up being 1/2, minus 7u to the negative 1/2 du. This is something we can integrate. So I end up getting u to the 3/2 divided by 3/2 minus 7u to the 1/2 divided by 1/2 plus c. Okay, if you do some keep change flip, you get 4/3 u to the 3/2 minus 14 u to the 1/2 plus c. Rewriting this in terms of x, you get 4/3 x plus 4 to the 3/2 minus 14 x plus 4 to the 1/2 plus c. Okay, and again, take the integral, or I'm sorry, take the derivative and check and make sure if it works. So this last problem here is kind of a doozy, so hang with me. We're going to go through the same process of this u substitution on steroids. Okay, so we are going to identify our u, which is our inside function. And then we find du, which is going to be 2 dx. Okay, now I don't see 2 dx anywhere in this integral. I do see a dx, so that's what I need to get over here. So I'm going to divide by 2. So I have 1/2 du is equal to dx. And then I need this x value. Okay, so I need to get x in terms of u. So I will have u minus 1 over 2. That is going to equal x. Okay. So then what you're going to do is you're going to substitute everything. So this is a definite integral. So the x is equal to u minus 1 over 2 times the square root of u, and then dx is equal to 1/2 du. Okay. So again, this is a constant, we can kick it out. This divided by 2 is also a constant, we can kick it out. So then I have u minus 1. Now the square root of u, I'm going to change it to u to the 1/2 du. Okay, and this is very similar to our last problem. We will distribute the u. So I will add the exponents. So 1 plus 1/2 is 3/2 minus u to the 1/2 du. Okay, now I can't integrate this, so I will get 1/4 u to the 5/2 divided by 5/2 minus u to the 3/2 divided by 3/2 plus c. And again, this is all evaluated from 0 to 4. So let's continue up here. So doing a little keep change flip, I get 2/5 u to the 5/2 minus 2/3 u to the 3/2 plus c. And again, evaluated from 0 to 4. If I distribute that 1/4, I get 2/20, okay, which ends up being 1/10. So I have 1/10 u to the 5/2 minus, well, 1/4 times 2/3 is 2/12, which is 1/6 u to the 3/2, and then 1/4 times the constant is still a constant, and we evaluate from 0 to 4. Okay, now this evaluation from 0 to 4 is in terms of x. You cannot plug it in directly for u, so you have to get this result back in terms of x. So I have 1/10. My x was 2x plus 1 to the 5/2. So now we can start to plug in and actually solve for this integral. And I'm sorry, we do not need this plus c because this is a definite integral. So we are good without it. That was my mistake. So if I plug in 4, I will get 1/10 times 9 to the 5/2 minus 1/6 times 9 to the 3/2. So that's the first part. Minus, and then if I plug in 0 for x, so this is going to go to 0, so I would just have 1. This is going to go to 0, so I would also just have 1. And so I would end up with 1/10 minus 1/6. Okay, so I'm going to do a little side math here. If I have 9 to the 5/2, that's the same as the square root of 9 to the 5th. Okay, which if you know how to simplify radicals without a calculator, you're looking for groups of 2. So if I have 5 9s, I have 2 groups of 2, so I would have 9 squared, and I would have 1 left over. Well, 9 squared is 81. The square root of 9 is 3. 81 times 3 ends up being 243. So over here, I have 1/10 times 243 minus 1/6, and then I have 9 to the 3/2, which is the square root of 9 cubed. Okay, and again, you're looking for groups of 2. Well, there is one group of 2, and you have 1 left over. So you have 9 times 3, which is 27. So you have 1/6 times 27 minus, and then 1/10 minus 1/6. I'm going to let you do the math on that one. You end up getting -1/15. Okay, so now over here, 1/10 times 243, that ends up being 24.3, minus 1/6 times 27. Well, 27 over 6, you can reduce that by 3, and you get 9 over 2, which is 4.5, because we're dealing with some decimals here. And then plus negative 1 over, or plus 1 over 15. Okay, again, we're going to have some mixed numbers here. But 24.3 minus 4.5 is 19.8 plus 1 over 15. You can use your calculator, or you can do some really cool math and get those common denominators. But 19.8 plus 1 over 15 ends up being 19.867. Okay. Now, you can check this using your graphing calculator. Remember Math 9, and plug in your integral. And you will see that it ends up being the same thing. Okay. So that's how you do the super U substitution, or U substitution on steroids. Now I recommend that you look at page 604 of your homework, and that's where this is going to come into play.